Hey everyone, thanks for watching. Today we're going to be talking about linear functions. We're going to start off with the definition of a linear function. A linear function is what it sounds like. It is a function that is linear. So it's a function that is a line. And in order to know what a linear function is, we need to know what a function is. And in a function, for each input, there is one output. What I mean by that is when I put in one value, I'm going to get out the same value every single time. For example, let's say I make $10 an hour. Every time I work 1 hour, I'm going to make $10. 1 hour, $10. 1 hour, $10. It's not all of a sudden going to be 1 hour, 20, 1 hour, 100. It is 1 hour, $10 every time. So we've got for every input, there is exactly one output. And for a linear function, that is a function that takes on a consistent rate of change with a specific y-intercept. The function has for every independent variable, which is the input, there is one output, which is the dependent variable. Linear function is a function whose graph is a line. There is a given rate of change and a y-intercept. We know the rate of change to be the slope, which we represent with an m, and the y-intercept is our starting point, which is represented by b. Typically, you will see a linear function written as y equals mx plus b, and you can also write it as f of x equals mx plus b. Typically, when we're going to evaluate a linear function, what evaluate means is we're substituting in some value and we are trying to determine what the output is for that value. So in order to evaluate a linear function, what you do is you substitute in the x and you determine what the y is. So you're going to first substitute the value of x into the equation. Then you're going to simplify, which typically means you'll probably multiply the slope times that input value and then add the intercept. And then you are left with the result of whatever the output is. This is true when you are in that y equals mx plus b format. If you are not in the y equals mx plus b format and you have x and y on the same side, you will need to isolate the y variable in order to evaluate that linear function. So in a linear function, we've got a line. It's either flat, it's got a positive slope, a negative slope, something like that. We know it's a function. For every input, there's an output, but we want to identify the domain and the range. What is the domain and what is the range? A domain is the set of all possible x values of the function. Domain goes with x. I like to think of x comes before y in the alphabet and d comes before r in the alphabet, so domain and x go together. The range is the set of all possible y values of the function. When you're dealing with a linear function, a line goes on forever. It does not end unless you define it to be some sort of piecewise function. Linear graphs go on forever. They increase forever, they decrease forever in the x, they increase forever, and they decrease forever in the y. Depending on whether your slope is positive or negative, it doesn't matter. They're going to take on all x values, and they're going to take on all y values. Unless you've given some other parameter, a typical linear function, the domain is going to be all real numbers for x. Your teacher could have you write notation in different ways. You could use the symbol for all real numbers, which is a capital R Some books use it with a bar on the R. You can use 2 lines. It depends on the notation that your teacher is giving you. So some texts you might see that the R is actually bold or thick on that left side, or you could do 2 lines. You could also say the set of X such that X goes from negative infinity to positive infinity if you're using set notation. Again, it just depends on, they're all correct versions. It just depends on the way that your teacher wants you to write this answer. But essentially, it's every single value. X goes from negative infinity to positive infinity. You could also say X such that we're going from negative infinity to X to positive infinity. Those are a couple different ways you could write it. For the Y values, again, you're taking on every single Y value. This is also going to be all real numbers. So you could use that notation of having the bold R value or the 2 lines to represent all real numbers. And you could say then the set of Y values from negative infinity to infinity, or from negative infinity is less than Y is less than positive infinity. Those are all appropriate ways to write your domain and your range. Now, infinity is not a number, so you're not using closed, you're not doing an equality of less than or equal to on those values, and you're not using brackets, you're using parentheses when you're talking about that notation. When we're talking about a linear function, the general graph, I'm going to speak about the parent function, which is the most basic general function where y equals x. That general function of y equals x is going to have the y-intercept of 0 and a slope of 1. This is the general parent function. All linear functions stem from this parent function. If you're wondering kind of what parent functions are, I'm going to talk about transformations in one of my next videos. And a transformation stems from the parent function. Just like children stem from their parents, you have this one general idea of what the parent function is, the most basic function, and then you can manipulate it. You can shift it up, you can shift it down, you can stretch it, you can shrink it, you can do all sorts of manipulations, you can reflect it. But in this case, y equals x is the parent function. It has a slope of 1 and a y-intercept of 0. A slope of 1 means that for every time you increase 1 in the y direction, you increase 1 in the x direction. So you're going up 1 and over 1, up 1 and over 1. You're going up and to the right. You can also go down and to the left. Those are the same thing. If you do the opposite in both directions, you're getting the same idea. How do I graph if it's not just y equals x? There's multiple ways you can graph. You might have learned how to graph using the slope and the intercept. The most basic way to graph a linear function is to create a table of values. If I'm going to create a table of values, let's say I wanted to sketch by hand the function y equals 2x minus 1. When you create a table of values, you are picking individual x values and you're inputting them. They're the independent variable. You choose a few values of the independent variable, substitute them in, you evaluate it, and then you get these coordinates because your linear function is graphed in the coordinate plane. And then you graph those coordinates and connect them. A linear function is always going to be a line. If you get some sort of jagged edge, you've done a calculation incorrectly. So if I was to create a table of values, some people just do x and y. But let's say I pick some x values. I'll do -2, -1, 0, 1, and 2. And then in the middle is where I actually do the calculations. So I'm going to find that f of -2, I'm going to evaluate that. That means that x is -2. So I take 2 times -2 minus 1. 2 times -2 is -4. -4 minus 1 is -5. And that gives me the ordered pair -2, -5. And I can plot that point. F of -1, I get 2 times -1 minus 1. 2 times -1 is -2, minus 1 is -3. And I have the ordered pair -1, -3. F of 0, I have 2 times 0 minus 1. 2 times 0 is 0, minus 1 is -1. I have the ordered pair 0, -1. f of 1. I have 2 times 1 minus 1. 2 times 1 is 2, minus 1 is 1. I have the ordered pair 1, 1. And then finally f of 2. 2 times 2 minus 1. 2 times 2 is 4, minus 1 is 3. And I have the ordered pair 2, 3. In a line, you are consistent. If you're increasing by the same amount for x, your y should be increasing by some other value as well. Like if I'm going to increase by 1 and 2, then I should increase by 1 and 2 each time for each. X increases by 1, y increases by 2. X increases by 1, y equals increases by 2. Because our rate of change is constant. We have the same rate of change for that line. So when I'm graphing my line, remember that x is horizontal and y is vertical. I graph the x first and then the y. So I'm going to go back to label my graph. I go to the left 2 and I go down 5 and I make a dot. Be better if I was on graph paper because then I would have consistent spacing. -1 is left 1, down 3 for the -3 and y. 0, 1 is not moving left or right for x, but dropping down 1 for y. 1, 1 is to the right 1 and up 1. And then 2, 3 is to the right 2 and up 3. And then what I do is I create a line through those points for my graph. And that's how I graph using a table of values. If I wanted to graph using the slope, I plot my y-intercept and then I use my slope to create new points. That's the next level of graphing. I encourage you to look into graphing by slope and intercept if you haven't done that before. The next piece of information that we use for graphs is we determine what our asymptotes are. Asymptotes are values that your graph approaches that never touches. What I mean by never touches is it never takes on that value. So if I'm getting closer and closer to 1, but I don't take on the value of 1, then 1 would be x equals 1 or y equals 1 would be an asymptote. Because our domain and our range are all real numbers, I have no asymptotes. Linear functions do not have asymptotes because x is going to take on every single x value and y is going to take on every single y value. So linear functions do not have asymptotes. I mentioned parent graphs and transformations. I'm going to do a separate video on transformations, but a transformation is basically where you take that parent graph and you either shift it to the right, to the left, up, down, or you change your slope or you reflect it. And there's many different ways that you can do that, but transformations work for all types of functions. You basically start with your parent function and then some sort of manipulation is going to adjust that, and that deserves its own video. Thanks for watching. Have a great day.